Hi, Chris Kuzmal here. Well, this is what it means to code. I made the following changes. First of all, just so you know, on line 60, I added an increment to I and a decrement to, an increment to j and a decrement to I. And then on line 62, I put in an increment to I and a decrement to j, which is consistent with the Corman-Liserson and Rivest pseudocode. They have that for a reason. But because they have a do blah while, they don't. It's a little less obviously seemingly ridiculous, because why increment I and then why decrement I and then increment it? The answer is, in the event that the conditional on line 63 or 64 and 64, but if neither of those changes j or I, we need to change j and I anyway, because what that means is if neither of those fired, that means that the pivot value is the same as a of I and a of j. And if that's the case, then we still need to move I and j, okay, which is fine. But the problem is if we don't want to move I and j on the first iteration through. Okay, so that's kind of why that happens on line 60 and line 61. Now, correspondingly, I had this lazy fix, and I put in lazy fix because I hadn't really thought about it. I knew, sort of the back of my mind tickled me and said that's not going to be necessarily a good thing, so I want to take note of it. I did, thank goodness, because after I put in those other fixes, I did not the decrement to j c no longer was necessary, but that was only apparent because I went over to the other code for partitioning, testing the partition, and there I wasn't dependent upon the return value of partition being correct. I just was checking on partition, which, incidentally, the additional thing that I discovered was that when you do a partitioning, and let's look over here, it doesn't show up here. We'll have to look at the actual test code. Partition test 8, let's look at, for example. Here we see 3141, and one of the possible acceptable answers is 1143. That does partition things, and I was kind of getting confused when I was trying to debug, because the 3, at a certain point in time, this 3 and this 1 will swap. The 3 at the beginning of the array and the 1 at the end of the array will swap. And in my mind, I'm always comparing things to that particular 3, but I'm not. It's just treated as any other element in the array. The value for the pivot is 3, but that doesn't mean that the value 3 is going to be located at the juncture the boundary between the collection of values less than the pivot and the collection of values greater than or equal to the pivot. So no worries, I think. It will be interesting to see whether or not we have any problems if we have multiple values equal to the pivot, because that's sort of a test case that I have not developed yet. Nevertheless, the good news is that at least for our very small test case for sorting, we pass now as a result. And the changes, like I said, the changes are on line 62 and 60, and also I believe that this lazy fix gets undone. And that's all there is. And so next time we will add some more test cases with, in particular, in mind, multiple pivot values. Multiple values in the array are equal to the pivot value. And I want to make sure that that test case succeeds.